Welcome to Adapt Now, the ABB podcast series on adaptive execution. Hello, welcome everybody. This is Dan Oberle with another edition of Adapt Now, ABB's series of topics around ABB adaptive execution. Today we have Brad MacDonald from Canada, who's joining us on the phone to talk about Select IO and its role in the ABB adaptive execution methodology. Brad, hello.
Hi, thank you for asking me to participate on this great topic that I'm very passionate about.
That's great, Brad. Maybe we can start with a little bit about your background.
Yeah, I joined ABB 33 years ago and started in the hardware software side of automation and traveled the world implementing our technology on all kinds of bases from mining, pulp and paper, and oil and gas. And about 12 years ago is when I switched over to the marketing side, which I love immensely because you get to play with the latest technologies and drive that out there to the marketplace.
Great. Well, that's awesome. I think today the topic with Select IO, maybe you can just start with ABB's IO family and how that family fits into ABB Adaptive.
Yeah, and that's a good question. I think everyone's looking for the silver bullet that one IO solves one problem or all problems. But really, I think each site, each application requires its own needs. So you really want a flexible or adaptive solution that meets the needs because you have, the big differences greenfield new plants, but you also have a large installed brownfield site. So how do you manage the various needs of those? So you want to have a technology that supports local and remote. Those are the two, big drivers in IO. But you also want to say, hey, a lot of customers are driving IO now to smart technology. So you have to have a field bus solution to deal with IO. And I did a project where, we did a project, 10 years ago now, 100% of the IO was field bus. That wasn't even conventional. We did another project that had maybe 75% field bus. So you want to be able to have a solution that covers all the needs, be it local remote, single channel versus multi-channel, field bus, and the mixed solution that meets the needs of a greenfield where you want to minimize the IO in the control room and maximize putting it out in the field. But a brownfield, it's all historically, it's all sitting in a cabinet. And if you're upgrading a 40-year-old technology, you want to be able to something that can really go high density in that space and be very, very cost effective. So our ABB offering is very flexible to meet all those challenges.
Okay. So with Select IO, when was that introduced?
So I was part of the global marketing team, and it was introduced, 3 years ago at our Automation Power World in Houston with our big launch. And it is looking at a challenge that is faced, and we'll talk more about that later, but the challenge of new greenfield plants, putting IO out in a plant, but trying to minimize the cost of that IO through the installation, but more importantly, minimize the impact that changes and allow you to make changes without having huge cost overruns. So Select IO came onto the market using a single IO channel approach. So you just define, I need this type of IO here, plug the module in. That's all the engineering you do. In the old days, obviously, you would have to spend a lot of engineering to define, I have to put this module with 18 or 16 points on it, and I have a different module needs. The cabinet suddenly gets bigger and gets crazier. So we'll talk more about the specifics of Select IO, but it is just a single channel, simple. You want what you want, you just put into the slot approach.
Okay, and what does that do for you? What are some of the benefits?
So what does it do for you? So I think there's many things that roll out of it, especially the adaptive idea. The traditional approach, when you did an engineering project, I was a project manager at one point in time, we'd sit there and do a design freeze date because we had to build cabinets, and we'd have to build cabinets with cross wiring, and we'd have to engineer this to the nth degree to make sure. And changes came along. They added IO. Oh, that I thought was a digital, now it's an analog. It created a lot of chaos in the whole engineering and change management. So what's the Select IO single channel idea is you can build one cabinet, a standard cabinet, whatever size of unit of IO you want, be it 96, 60, 300, pick the standard size you want, but it has no IO in it. It has slots for that IO in it, but you build this single cabinet, and then you just say, okay, I need 100 here, 100 there, 100 there, 100 there. You buy those cabinets, and then when the engineering finally gets finalized, oh, I put an analog here. I need to put a digital in there. And there suddenly the design of that freeze date moves from right at the beginning of the project to being eliminated, and you just build cabinets as needed for IO quantities you assume, and then you put the IO actually in that you need. So change management is a huge factor that's been eliminated out of the project, and it really makes managing a project so much easier, allows you to move that execution freeze dates and all that design work much later on in the project. And we'll talk later about a project I involved in, how that did worked. But you can now move everything to just-in-time engineering. Just say, I need 100 cabinets, and the IO will I'll order that when I need it.
Okay, Brad, I'm curious now. We're going to talk about some examples you mentioned, but the design phase, I'm always wondering if the Select IO or the IO family plays a role in helping influence that by having that flexible selections. Do you have any scenarios or examples of that?
Yeah, so over my years, in working on projects, you want to get involved as sooner in the design phase than later, because that's when you can do this concept of influence the way the project's doing. And for me, it's always, how can I do this to provide a lower cost solution, but not losing any technical advantages and maybe giving more. So I've seen it, in the old days, we would mount IO in the MCC section, and then that would make things much more flexible rather than say, oh, we got to wire this all at site and there's a whole bunch more testing when it could be done in the MCC. So our flexible IO approach, when we bring that toolkit at the design phase of a customer who hasn't finalized that, then we can really take advantage of stuff. A lot of times the MCC IO is conventional. We can say, hey, why don't we go with a field bus? We can eliminate a lot of extra cost there. And we look at the conventional IO, what do we look at? Do we have IO that going out the field? Hey, can we mount our IO out there and eliminate all that wiring and engineering and effort and testing of that IO because of that infrastructure putting the IO local versus out in the field? And so this is where we've been able to, as a company, guide customers into the right solution and products that meet their challenges and meet their needs and provide them the most efficient, not just a CapEx perspective, but long-term operation cost, because that's plants are running 30 plus years, and you want to be able to have a solution that keeps that cost low and allows them to work with it through the years as it goes.
Mm-hmm. Great. Well, you mentioned you want to talk about a project success, and I think it had some elements around commissioning and even around the ongoing operation that the adaptive approach has played a role via Select IO. Can you get into that project a bit?
Absolutely. I think this project was an amazing project just because it hits on all these kind of things that we're talking about, adaptive control and having a solution that best meets the requirements. So we have a natural gas company, SemCams, up in Canada, that was putting a new gas plant in. So for the people who are not familiar, you have gas that comes out of the ground that has things in it. Sulfur being one of them, you have to remove, so it cleans that out, and they call that sour gas. Also has other things than just natural gas, has heavier gases in there which they can pull out and then sell as propane, etc. So this gas plant is a very modular design by its nature of its business, and has various packages that come together. So it's not like you design a plant, you design packages and fit all these pieces of units together to create this plant. So the site was called Wapiti in northern Alberta in Canada. It was there to produce 200 million cubic feet per day sour gas. And it was very interesting. When we started quoting this project, we were doing an IO count of 1,300. And when we finished the project, we got to an IO count of 2,400. And wow, that's a doubling of IO. How did that manage through the case of the project? So, first of all, not one IO solution was used. They generally wanted all the remote IO to be out in the field using select IO in the -40 environment. Perfect for that. That eliminates all the multi-core wiring that is needed to connect everything together. They also had local IO. That was the MCC IO, both 300 IO. We used our S800 IO product. Why? Because it's multi-channel, it's low density, low cost, can get right in the MCC, and therefore we have the best of both worlds. Local IO S800 and the remote IO with select IO. So when we originally, I said, started this project with 1,300 IO, we quoted a project. By the time that they're designing their standard cabinet, they only designed one cabinet that fits all. They had 1,800 IO. So they came up with 24, well, at the time, 23, 24 cabinets. And by the time they were manufacturing, seeing IO going more, they built 27 remote IO cabinets that fit, that could go in the -40 environment, as well as the hazardous zone of Class 1 Div 2. So they went to commissioning of this plant, and wouldn't you know, they added more IO and hit up to 23. I was a project manager. I would have had a design freeze at the kickoff meeting, decided probably a month or two into the project. There was never a design freeze date on this project.
Okay.
They just simply said, let's just build the cabinets, and if we need more IO, we build another cabinet. And when they got to adding IO in the field, they just had a space. They put the IO. Oh, there's an analog. Screw it in. They'd be there. Oh, we have this IO point. What's the closest cabinet? And they'd wire it to it. It was so simple. And from an ABB perspective, all I saw as a change order was the cost of the IO. From the day one in which we sold it to the day it commissioned, that cost of that IO module was the same for the project. Rather than the conventional ones, oh, we got to do a whole bunch of re-engineering. Maybe there's cross-wiring that's got to be done. Oh, I got to add a whole module into here to accept more IO. It gets very complicated and very expensive. Here, it was the same cost from start to finish.
And the
so
impact on the schedule then,
sorry.
The impact on the schedule then must have been, minimal.
Absolutely. So, automation is always at the end of the startup of the plant, always at the mercy of the construction and all that kind of work. Here, as well as we're always last to know, and there's a process design and we have new IO. Here, it was just simply be at the field. They were simply adding the IO, and it was done right away. They didn't have to, we got to re-engineer, we got to have someone work in a cabinet. It was simply insert, connect the IO, and you're done. So the schedule on this project, they started up 3 months ahead of schedule. I'm not saying ABB was the result of all that 3 months, but I can say automation was not the result of any delays of that startup. But typically, when we start up a plant, automation's always been the problem in a schedule. And in this case, it wasn't.
Good. That's a great story. And they're operating now? It's all up?
They've been operating for a year and a half. They
Okay.
started when it was -50 in January 2019. It was very cold, and they were able, doing commissioning and IO checks in this cold weather because the IO is out in the cold, the devices are out in the cold, and they were able to run everything and bring it up and running. It's going now through its second summer. And running quite effectively.
I thought you said the design spec was -40. for the IO?
Yeah, so what they did, because the environment is a little colder, and inside the cabinet maybe we can do -40, outside can do -50. They put heaters in the cabinet just to ensure that if it went below -40, because it can, that it would support that. But there also were some other devices in that cabinet that couldn't go below that. So I think it was -20. So they put a heater to keep that temperature warm. But our stuff would have run. If you would have turned the power off and then a cold start at -50, that would have been a problem. So the heaters, again, are protection for that.
Mm-hmm. So is there a project size that sort of dictates the use of Select IO and some of these benefits, or can it be done on any project?
I think, my first answer is it can be done on any project, but the scale and magnitude of its savings, as you scale up the project, the savings will get more and more. And you say, well, it doesn't make sense, 100 to 1,000, like what's the difference? Well, when you get to projects get bigger, just the overhead of change and the complicatedness of a whole big project adds a lot of overhead of, I'll call it red tape management of change. But when you bring a product like Select IO into it, doesn't matter if it's small or large, it provides the same savings. But in the bigger projects, we see much more savings in how the project's executed, how the schedule is managed, and how we can parallel our efforts now. But as I said before, engineering would have been done in a sequential thing. Now we can go in parallel, where we can build the hardware cabinets empty, ship them to the fab yards, and wait till the IO gets loaded. And in parallel, we're running the software work. And that provides that benefit. And larger projects, by their nature, consume a lot more, I think, overhead in the engineering red tape, and they can really benefit.
Great. Well, that's a real. I love your enthusiasm there, Brad. I mean, it's been a pleasure to talk with you today, and
thank you, Dan.
I certainly learned something and enjoyed our discussion. With that, I'll let you go, and you have a good day. And when we have another new technology that's being introduced, I'll be sure and give you a call. Talk to you.
Thank you. I look forward to it. Thank you very much.